The Federal Bureau of Investigation, the FBI, has joined the NSA and others in suggesting that you should not use C++ for software development. And they make the case, as has been made, that it's tied to memory safety. The problem with that is that while that sounds credible, it actually isn't. It isn't true. We have these things called frameworks. That's where the starting point is. You have these things called frameworks. And that's the thing that most people miss. Frameworks are tools that get you out of a lot of trouble. In software development, frameworks is the thing that you use so that you're not always building everything from scratch. Many security issues that are introduced in software can occur through the attempt to reinvent what has already been invented. Now, Java, Python, and many other languages also can have these memory issues. It has been proven in academic research, and it's been proven in the field. It's simply easier for an inexperienced and I'm not going to say incompetent, but no, not incompetent. That's not appropriate. For an inexperienced and non-diligent software developer using C++ or C to introduce memory issues. It's easier for them to do that. Doesn't mean that they will. Especially if they are managed by, supervised by a team or leadership that has quality assurance processes to verify that they are using the right mechanisms for writing code in these languages that use the best practices in security. There are evolving best practices. You don't want to use the security best practices of 5 years ago or 10 years ago or 15 years ago. You want to use the best practices of today. The best practices of today will allow you to write code in C on C++. And let's just say C++, that is the focus here, that don't have these issues that they talk about. Now, you can have memory safety issues from the improper use of pointers, and yet pointers provide a irreplaceable mechanism for improving the way software works. There are some things you cannot do if you don't have access to pointers. So the thing of it is that memory safety is not the only thing that causes security problems in software. It's not the only thing. It's simply the most common thing in the past, but it's becoming less common as we move forward in the future. And we have matured the computer industry to an extent where the actual hardware, the physical part of the computer, plays a role in the security and the reliability of software. We have older standards such as ECC, error correcting memory. We have problems in the past with Intel processors, Spectre, meltdown, and spoiler vulnerabilities. That's why I switched off of Intel and I switched to AMD. That was the initial reason for that. Spectre, meltdown, and spoiler. It don't matter how secure you think you've written the software. If you got a bug in the computer processor, you could use Rust all day long. And I'm not against Rust, actually. I am pro Rust. I am pro Rust. I'm actually pro everything. If you really want to know the truth of it, I'm not against any one programming language. I'm not against them. But I use C++ and I use C. I use C#. Those are my three. I do the 3 C's. I use the 3 C's. Michael, as far as software capability, software programming capability, I'm primarily the programmer of the 3 C's. C, C++, and C#. And you could use C#, you could use Java, and those are known to not have the memory safety issues that you would have in certain ways of writing C++ code. Again, it's how you write the C++, right? But even if you use a language that is on autopilot in terms of the memory management, and you still got bugs in the processor, in the chips themselves, you haven't accomplished anything. See, a recommendation of this magnitude is only useful if it solves the problem. If it does not solve the problem, and let's just say even in the best case, it merely reduces the level of the problem, reducing it still means you have exposure. And that exposure can be anywhere from a small business to a major cloud infrastructure where you have a significant data breach. So the reality in today's time, because I really don't want to say this, but I have to say it, is that we have some compromises in hardware, not software. Yes, we got compromises in some softwares as well, but we have compromises in hardware even today that I'm not even going to talk about them on this video. You'll find them on your own, because I don't want to put anyone down here, right, as far as hardware. But you have microcontrollers and you got CPUs that have vulnerabilities in them. And whether they are based on the x86-64 instruction set in architecture or the ARM instruction set in architecture. Even the custom ARM implementations in mainstream product have some known vulnerabilities. But the majority of those vulnerabilities are predicated on you having physical access to the computer. There is, in the latest versions of these chips, to my knowledge, it's not known that you have vulnerabilities on the basis of remote code exploitation of the hardware, as far as I know. But some of the older chips, most definitely. So the thing is that C++, and the reason why I take a contrary position on this recommendation from the NSA and from the FBI is for one fundamental reason. I don't take a contrary position because I think C++ is the best programming language. I like C# more than anything. It's my favorite. I'll admit it. It's my favorite. But I use C++ because it can do things that C# cannot do. And I'm not alone in that. Even Microsoft, who created C#, believes that. They just don't say it. But it's not in what you say, it's in your actions. Microsoft's very actions and that of the Linux community, their actions show that the FBI and the NSA is wrong. You see, the elite programmers and the senior-most architects of operating systems and major software, I'm talking about Microsoft Office, Word, Excel, PowerPoint. Hey, I've always said, if you rewrite Word, Excel, and PowerPoint in C#, then you have a point. If you rewrite, I'm talking about top to bottom, not a lick of C or C++ anywhere, right? See, Excel, Microsoft Excel can't do what it does without C, being written in C and C++. Can't do what it does when we're talking about when the spreadsheets get large and you start seeing things start getting real interesting with multiple tabs and formulas moving everywhere. You can't do that without Excel itself being written in C and C++. Same for Word and PowerPoint, right? So if you rewrite, and I mean a full rewrite, Word, Excel, and PowerPoint in C#, and you know what the first thing that will be said when anybody suggests that? Oh, you can't do that because you have all these years of code and it would be a waste of investment to do that, to rewrite it from scratch. And you would introduce bugs that would jeopardize the quality of the software that people have come to expect. They make the point I am making every time they say that. Every time somebody talks against converting a legacy product or project or platform or system to a new platform, language, implementation, that is actually what I'm saying why the NSA and the FBI is wrong on this. It's because the vast majority of the software you can't see that you depend on to make the software and tools that you can see work are based in C and C++. Like, for example, every time you go online, any online activity, 100% of all online activity, 100%. The front end might be JavaScript that was generated through TypeScript. And any programmer know where I'm going with this. The front end might be JavaScript that was transpiled from TypeScript. The server side might be ASP.NET Core, PHP over Laravel, or Python over Django, or whatever. The back end might be Node.js, MySQL, SQL Server, or Oracle. And you might have all of this plugged into microservices on AWS or Azure or GCP. But every last bit of it runs in an operating system that was written in C and C++. So if C and C++ is only allowed for those that make operating systems but not allowed for everybody else, that's not right. So you're saying that only the people that make operating systems can use C and C++? But what about the actual server itself that runs these higher level languages? Node.js runs off of Google V8. Google V8 is what makes TypeScript and Node and all of that go. And V8 is written in C and C++. Apache Web Server is written in C and C++. Nginx, Microsoft IIS. You know? So the parts that you can see mislead you into thinking that they can replace the parts that you can't see. That's the failure of the analysis from the NSA and the FBI in terms of the implications in the actual utilitarian way in which these things come together. And you cannot advance the state of the art without these. And you can't even rewrite these things in Rust. Why not? A couple of reasons why. Number one, companies like Microsoft and Google, they're not strangers to spending a cool $1 billion. Just one though, not 2 or 3 or 4. There's a limit to how much they're going to spend on a conversion project. But they're no stranger to spending a cool $1 billion on trying to convert something at a large scale. They're not a stranger to that at all. But you want to be on video? Come on.
For the next one.
Yeah.
That book.
Yes. Coloring book? This is wonderful. Come here.
That's round.
Yes.
That's round. That's round.
Yes. Come here, little princess. Come here. All right.
That's.
Yeah. See? Look at you. You see yourself?
This is a Band-Aid. A Band-Aid.
Your Band-Aid. That's right.
Yellow.
Mm-hmm.
Red. Pink.
Pink.
Willow.
You know your colors?
Blue.
Hold on. Let me pause this. And so, yes, you can't replace all of that, but yeah, they spent a cool $1 billion on infrastructure, right? And yeah, I'm trying to regain my thought there. But so they're not a stranger to spending $1 billion on conversion, but they're not going to rewrite all that code. So yes, they have spent $1 billion before on various improvement initiatives with their infrastructure, programming languages and tools, and most especially the security of their platforms. But the thing is, there's a limit to that because it would cost way more than $1 billion to do the level of conversion that third parties have in mind. It would cost more than $1 billion to do that. And that would, I don't think that would necessarily erode the profitability of these organizations now, at least not now, not at this time. Maybe many years ago it would. What I'm really saying is they probably could afford it. But there's some significant doubt that it would actually work. Because many of these organizations, these major tech companies, they have been able to operate largely without significant downtime, without significant exposure in terms of errors and failures and a range of problems. perhaps the most significant issues we've seen over the last 30, maybe 40 years when it comes to major tech companies and their initiatives in the grand scheme of things has been interoperability. That's really been the biggest issue of the last several decades, has been the matter of interoperability. Interoperability has been an issue on the basis of control or just motivation, you know, what they call not invented here syndrome. But most of that has largely been addressed. You now have interoperability. In many cases, at least at the cloud level, at the network level, in terms of how information and data moves. Now, you don't have interoperability at the API level, at the level of operating systems. So there's still, so your different operating systems, they are not interoperable with each other at the operating system level. So you have a problem there. And that bleeds into many of the applications. And so, for example, word processors and office suites between the major operating systems or those that maintain the operating systems, there's better interoperability now, but it's not where it could be, right? And there are many reasons for that. And so, to the extent that you do have interoperability, though, it has been defined based on these languages C and C++, right? And so, and then you have language bindings and you have APIs layered on top of that make that work. So there has been a movement to rewrite significant portions of operating systems in Rust. I've seen significant resistance to that in the Linux world. I've seen significant resistance to that in the Apple world. And when I say significant resistance, I'm not saying that the people that run Linux resist this, but many of the software developers that participate in the cultivation of Linux resist this. Apple hasn't staked a position on this, as far as I know, in any major way, but you also don't see a huge amount of enthusiasm from Apple in this direction, because Apple has their own programming language, Swift, and if they had it their way, they would continue to invest in Swift. And Microsoft has stated they would love to switch to Rust, and they've made significant efforts to switch over to Rust as far as the operating system goes. But out of everyone involved, I think that one's going to be the messiest when all is said and done. That's going to be very messy. We'll just have to see. But I just wanted to weigh in on this recent news about the FBI suggesting that C++ shouldn't be used, and just to note that C++ will be used, and if it was forbidden to use it, it would grind many projects to a halt, because there are many advanced platforms like robotics, electric cars, flying cars, drones, whether they're military or civilian. There are many of these types of platforms. You can't yet fully define them 100%, even by the year 2026. I think it was 2026 that the FBI said no one should be using C++. But even if it was 2028, that's still too short of a time to see this occur in any responsible way. But it may very well be the case that it's simply a position that has been taken to try to encourage the acceleration of a switch to other languages. And the programming community at large would be fully capable of switching over to Rust. But again, the problem is that you have, well, no one actually has the code estimates, but I would just make a informal guess that there are billions of lines of code written in C and C++. Billions. Not millions, billions of lines of code. And you could take two strategies. You could try to just convert the big rocks and leave all the little rocks alone, right? So you would try to change Linux and Windows and Mac OS and iOS and all of that and Android over to Rust. And you would try to take major projects like Google V8 and you would try to change the underlying parts of Java and C# to be implemented in Rust rather than C and C++ as they are now. You could try to do major things like that. You could try to change Microsoft Office over the C or over the Rust. You could do major high visibility projects like that, right? Or projects you think that constitute the widest exposure, right? But you still have huge interoperability issues that will come up. You still have unforeseen bugs that will come up, that bugs and flaws and defects that don't exist now. Who's going to be accountable for those flaws and for those defects and for those failures? And so there is a sense of wanting to compel a shift that if you were to succeed in doing that, would be great business for those of us who are in consulting. Great business, but it ultimately will devolve into a level of chaos as you get increasing resistance from your most relevant contributors. And what I mean by that is you have people that are they are MVPs. They're the most valuable players when it comes to building Linux, building Apple, the actual Apple technology, building Windows. And if you throw them off their game, you may not have people that can step up to the plate at the level that they were able to function using C and C++ and do it in Rust at the same level, right? You got some talent that has switched from C++ to Rust. You have some talent, but they were not the talent that was simultaneously the ones that you would turn to for the advancement of these major platforms that everyone uses. So I'm not going to say that you take this advisory with a grain of salt, not at all, but that you may have very legitimate reasons for continuing to maintain and initiate projects in C++, and those reasons are not to be taken lightly. And I think the vast majority of people would support those that decide to continue in that direction. So with that all said, I just wanted to weigh in on that. And I think that the future of software development and computer technology, we can still call it that, even though we now just call it phones and appliance like computers and tablets. But I think the future of these things is going to get real interesting. And I'll have something to say about artificial intelligence later on another day, because I have become aware of some things about artificial intelligence. But let's continue to be wise in how we proceed with technology. Let's not become victims of marketing and false promises. Let's build what we have to build the right way with the best tools. And there are many choices in what we would call the best tools, but some are just, let's just admit, they're just too expensive at this stage. And though they may have some parts of them that are very mature, the full maturity is not there to a level that you can bet an entire project on some of these tools that people uphold as the solution to all that ails us with computer technology. So with that, thank you for listening if you've listened to all of this, and I will see you later.